Hello, and in this video we're going to do some transformations, and I've titled it Doing Transformations because you can also, in exams and specifically GCSEs, be asked to describe a transformation that's already been done. So there'll be another video where we describe transformations, but this one is the actual doing of them. And I've got here a nice little triangle, but you can have any shape, and I've got one of each of the transformations just to give you an idea of what to do. So if it asks you to reflect a shape, it will tell you the line in which to reflect it. It might say the x-axis, or it might say the y-axis, or it might give the equation of the line, which is what it's done here. Y equals -1 is this line here. Now, we're not very good at any symmetry really as humans other than vertical symmetry. So if it was an exam, I would spin my paper round to have that as a vertical line. It's much easier to see that you've made a correct reflection vertically than it is to do it horizontally. But never mind, we'll persevere. And what you want to do is just remember that the reflection is the same distance inside the mirror as it is away from the mirror. So it's 2 away from the mirror. This point here is 2 away from the mirror, so it's 2 inside the mirror. So I've already made a boo-boo because I'm going to go off the page here, but never mind, we'll just pretend that there's another layer of squares here. And you can either then think, oh, well, yes, I can see how it would reflect. It comes back here and it comes in there. Or you can just do each point and just say, okay, well, this point is 1, 2, 3, 4 away from the mirror at right angles. So at right angles, 1, 2, 3, 4 into the mirror. And same thing here, 4 away, 4 inside, and then do a dot to dot. So however it makes sense to you to do it, whether you do one corner and then just draw it in its reflected form, or if you do a dot to dot, absolutely fine. The key thing is that every point on this triangle should be, however far away from the mirror it is, should be the same distance into the mirror for the reflection. So that's the reflection one done. Translate 4 to the right and 2 up. Now this might be written instead as a vector. So you do need to know that for a vector, the top number is the left and right, and the bottom number is the up and down. So if I do it like this, this can be left or right is the top number, and down or up. And how do you know whether it's left or right? Well, if it's minus, then it's left or down, depending on where it is. And if it's a positive number, then it's right on the top and up on the bottom. So as a vector, this will be written 4, 2. And again, you just pick a point. So if I pick the same point and just count 4 and 2. So 1, 2, 3, 4 steps to the right, and 1, 2 steps up. And remember, that is the point Q. And so you've got to draw it from that point Q up and over and back. What you don't want to do, I see a lot, is people start here, they count their vector, but then when they get there, so let's say a different vector, maybe it was the vector of 1 minus 1. So this one moves 1 across, 1 to the right, sorry, shouldn't say across, 1 to the right, 1 down, and then people go, oh, well, it's moved to here, and so I'll draw the shape like this. And you're like, oh, hang on a minute, you've just translated that corner, but then you've changed it to this corner. So actually this corner hasn't moved 1, 1, or 1 minus 1, it's moved 1, 2, 3, 4 minus 1. So you've got to be careful that when you translate the corner, you draw it from the corner that you translated. Yes? And a good way to check it is to pick another corner and just count 1, 2, 3, 4, and 2 up, 4 right and 2 up. So just check another corner and make sure it's in the right place, and then you'll be fine. Okay, a rotation. Now these are quite tricky. Rotate 90 degrees clockwise about the point 3 minus 1. So 3 minus 1 is here. So I'm actually going to just get rid of that mirror line just to help things out here. There's the center about which we're rotating. And if you had tracing paper, you could put your tracing paper over, draw your shape on the tracing paper, hold your pen on the point, and actually spin the tracing paper round 90 degrees and see where it lands. But as I don't have tracing paper, I'm going to do it with a bit of an arm. I'm going to imagine there's like a robotic arm that stretches out, and it's stretching out across here. I'm just going to draw it in, and over here. And it stretches out to reach the shape. And then that robotic arm is going to rotate round clockwise. Where was it? Clockwise 90, and that should say degrees, but I forgot. 90 degrees clockwise. So it's going to spin round. So that's the robot noise, you see. And so it's rotated round. It's spun round. Okay. You also have to imagine the shape spinning round. So as that spins round, it's going to sort of rotate round. That's going to come down. And so this arm is still holding on to point Q, but now, if I just get rid of this line here so it's not all getting confused, so that's where Q is, but it's got to be rotated round. So it's going to come across, that up is across to the right, and that to the right is now down, and then the diagonal joins it up. So it's a bit tricky without tracing paper, but you can do it if you think about, like a robotic arm, and then you've got to visualize that moving around, or just move the page and say, well, what does that look like after a turn? Oh, it's pointing down with the point on the right. So you can draw it then just like that. Okay, and finally, I'm going to move to a different color of pen for this one, just so it doesn't get confused. I think it's going to go over the top. Enlarge with a scale factor of 2 the point, about the point, sorry. So that's where the enlargement starts. The scale factor of 2 means everything's going to get twice as big from this point. So -1,4 is here. It might go off the page again, I haven't checked, so we'll see. And not only is it getting twice as big, so it's not just a case of, well, I'll just draw it twice as big, lovely, there you go, twice as big. It's got to be in the right place, okay? So that's not gonna cut it. You have to think, okay, well, at the moment, it is this far away from the center. It now needs to be drawn twice as far away. So it is 2 right, 1 down. That's how far away it is. If it's twice as big and twice as far away from that center point, then 2, 1 becomes 4, 2. So that corner P is actually moving to there. And either you can do the same thing. You can say, oh, well, 3, 2, and then extend it, and 6, 4, and plot each point and dot to dot like we did with the reflection. Or you can say, okay, well, now I know that that's point P, I'm just going to draw everything bigger. So this top side is 3, so now it's 6. 1, 2, 3, 4, 5, 6, and that's 2 down, so it's 4 down, and then join up the diagonal. So it's entirely up to you whether you, same as the reflection, do 1 point and then draw the rest, having enlarged it with a scale factor of 2, twice as big, or if you enlarge every point separately. But notice you can draw straight lines like this, so it's always worth a quick check with your ruler. Do those 3 points, that new point, that point in the center, does that sit on a straight line? And does that fit on a straight line? Obviously my hand drawing thing's rubbish, but you could check that that was a straight line, and if it wasn't, you'd think, oh well, maybe I've miscounted, maybe I've drawn it slightly wrong. And if it is, then it gives you the confidence that you have done it right, assuming you've read the question right, of course. So that's how you do transformations in a very sort of quick, sketchy sort of set of examples. If you have any further comments about that or questions, you can let me know down in the comments. But there will be another video saying, okay, if we've got a transformation already done, how can we describe that in words? But for now, cheerio.